Our first section that we have here is for tonight is section 1.7. And in this section, we're going to be analyzing graphs of functions, and then we're going to also look at some piecewise functions as well. Okay. So a couple of more things to learn about graphs. We can learn about symmetry when it comes to a graph. And so you'll see here in the words, I've kind of put how we can test if something is symmetric with respect to the y-axis, if it's symmetric with respect to the x-axis, or if it's symmetric with respect to the origin, okay? Now, if it's symmetric with respect to the y-axis, we can substitute negative x in for all the x's in our equation and still come out with, when we simplify it, if it's still the exact same equation, that means it's symmetric with respect to the y. If I put in a negative y for all the y's in my equation, resolve it for y, if I get the exact same equation, that means I have symmetry with respect to the x-axis. And if I substitute in negative x for all the x's, negative y for all the y's, and simplify and get back to the original equation, then that means I have symmetry with respect to the origin, okay? So I have a couple of examples here so that we can walk through them and determine if there is symmetry, and if there is symmetry with respect to which axis, okay? Or the origin. Or it's possible that it is not, okay? So for this first one, we have y equals x cubed. Okay, if I want to first start with respect to the y-axis, that means I'm substituting in a negative x for everything in here. So this is going to be then, we would have y equals negative x cubed, okay? When I simplify this, this gives me negative x cubed. That is not the same as my original. So no, this does not have symmetry with respect to the y-axis. Okay? Question. Let's look at it in terms of the x-axis. Okay? With the respect to the x-axis, we're substituting in a negative y for all of our y. So that would be negative y equals x cubed. And now we want to simplify it. So when we go here and simplify this, I divide both sides or multiply both sides by a negative 1. So I get y equals x cubed equals negative x cubed. That is not the same equation as my original equation. So this then would be no, I do not have symmetry with respect to the x-axis. Okay, and then the origin, when we test the origin, remember this one, we are making both a negative x and a negative y to test that. So we would have negative y equals negative x cubed, and that's going to simplify to negative y equals negative x cubed. We can simplify that one more time to give me y equals x cubed. As you can see, that is my exact starting equation. So I would say, yes, I am symmetric with respect to the origin for this equation. Okay? Question. Okay, let's look at this y equals x squared plus 5. So if we're looking at our y-axis, that is going to be y equals negative x squared plus 5. When I simplify this, I get y equals x squared plus 5. That is my original equation. So yes, there is symmetry with respect to the y-axis. Okay. We can test it for the x-axis. And the reason we do these tests is because when we graph things, it's good to know if there's symmetry to, if they're symmetric to the either the axis or the origin, because then we only have to graph out half of it, and then we can do the mirror image on the other half of the graph. So this one we have our negative y equals x squared plus 5. That's going to simplify to y equals negative x squared minus 5. That is not equal to my original equation, so there's no symmetry with respect to the x-axis. Finally, when we look at the origin, that's negative y equals negative x squared plus 5. And that will simplify to a negative y equals x squared plus 5. We could simplify that a little further and say y equals negative x squared minus 5. And again, no, that one is not symmetric with respect to the origin. Okay, question. All right, so this next one we have is x squared plus y plus 1 squared equals 4. So when we're looking at our y-axis, that is going to be negative x squared plus y plus 1 squared equal to 4. So this is x squared plus y plus 1 squared equals 4. And so you can see that is my original equation. So yes, it is symmetric with respect to the y-axis. When we look at it in terms of the x-axis, we end up with x squared plus negative y plus 1 squared equals 4. And you can see that, no, that is not the same as what we have above, because one of them has a negative y and the other one has a positive y. Okay. And then finally, we can test it for our origin. And that is, remember, we're changing both the x's and the y's to the negative. So plus negative y plus 1 squared equal 4. Let me clean that up just a little. So that is going to be x squared plus negative y plus 1 equal to 4. And again, that is not equal to our original equation. Question.
Y is not gonna be positive.
Y is y, which one?
The last one, is it the x? Then y is negative still. It's gonna be
Y is still negative, because if you did negative y plus 1 times negative y plus 1, right? And you do all this out, you end up with y squared minus y plus 1. So you have y squared y squared minus 2y plus 1, right? If you do this one out, you have y plus 1, right? So you still have y squared, but now it's plus 1 plus 1. So you end up with plus 2y plus 1. And so this is a plus and this is a minus.
Thank you.
Uh-huh. Let me I'm going to put this in just a different color, so I could leave it here on the page, right? So you can see that. I'm going to just move it up here, okay? Oh, and this is a squared, sorry. Okay. What I would like to do now is give you all about 2 minutes to work through this one right here. Work through, give you a minute to try and plug in both, test it for y-axis, x-axis, and the origin. And I'll pull those down. If y'all write that where the y equals absolute value of x minus 2, and then I'll put this up here so you can see each of those. So I'll give you guys a couple of minutes, and then we'll, when you come up with an answer or something, you can put it into the chat to say, oh, I think it's with respect to, the origin or whatever. You can put your answer there. The problem again is y equals the absolute value minus 2. Again, once you come up with if it's symmetric to something, put that in what you think it's symmetric to in the discussion board. And then if you think that it's none of them, you can put that as well. All right, so let's go ahead. I do see we've had a few people chime in that it is symmetric with respect to the y-axis. So let's look at that and see if that is the case. So we have, for our y-axis, remember we're substituting in a negative x. The absolute value of anything is still positive, so that's going to give me y equals the absolute value of x minus 2, which is the same as our original equation. So as some of your classmates pointed out, this is symmetric with respect to the y-axis. So let's see about the x-axis and the origin. So the x-axis, we're putting in negative y equals the absolute value of x minus 2. And so that would translate as y equals negative absolute value of x plus 2. And that is not the same equation. And then finally, we have with respect to the origin. And when we look at that, we have negative y equals the absolute value of negative x minus 2. And when we simplify that by dividing both sides by that negative, we get y equals negative absolute value of x plus 2. And again, that is not equal to our original equation. So the reason I didn't move the the absolute value when I moved it over, you could, right? But I left it there to help signify, because if I remove it, right, it would just be y equals x minus 2. While that is also correct, it doesn't look exactly like this. So I was just trying to eliminate confusion. But this here could also be y equals x minus 2. So they are the same thing. Does that help? All right. Any questions about how we can test for symmetry? Okay. So the next thing we will talk about is whether a function is odd or even. Okay. And so we want to identify when a function is even and when a function is odd, because that also helps us when it comes to graphing our functions, right? So an even function is going to be symmetric with respect to the y, and an odd function is going to be symmetric with respect to the origin. Okay. And so what does that mean? So that means that for an even function, when I plug negative x into my equation and simplify, I get the exact same equation. It means I'm symmetric with respect to the y. If it's an odd function, when I plug in a negative x into my equation, all of the symbols change for all of the terms to the opposite sign. Okay. And so we have a few examples here that we'll look through to help us understand better odd and even functions. Okay. So the first one here, we have x to the 4 minus x squared plus 2. And so what we want to do is we want to plug that negative x in. So instead of f of x, we want to do f of negative x. So that's going to be negative x to the 4 minus negative x squared plus 2. Well, anything to an even exponent, 2, 4, 6, 8, 10, 12, so on, is going to result in a positive value, right? Because a negative times a negative is positive. Negative times negative times negative times negative, still positive, okay? So this would be x to the 4 minus x squared plus 2, okay? And that is exactly what we started with. It is our original equation. So since f of negative x equals f of x, we would say that this here is an even function. Okay? Question. So let's look at this next one. So again, all we're doing, substituting negative x in for all of our x's. So this is negative x cubed minus negative x plus 3. So negative times negative is positive, times a negative is negative. So this is going to be negative x cubed. And then negative times negative is positive. So that's positive x plus 3. Okay. So this here is not my original equation, right? So it is not even. Okay. Now I want to determine, is it if I did negative f of x, right? So what that's saying is if I put this negative here, and I multiply all of this by a negative, right? That's what that is saying. Then I would end up with, if it was like that, then it would be, that's negative x cubed plus x minus 3, right? If I do what I did up there in the top and just distribute that negative to all of that, right? This is not f of negative x, right? This here is f of negative x. You see, this has a negative 3. This one had a positive 3. So they are not the same. So we would say that this one is not odd either. I'm going to change the shading of this a little better. Let's okay. So this problem here, we would say is neither. It's neither odd nor even. Okay. Question. Okay. So the next one here, we have f of negative x equals negative x cubed minus negative x. So that's going to give me a negative x cubed plus x. Okay. This is not my original equation, right? But now we want to test. Is it negative of the whole entire equation, right? So negative of the whole entire equation. So that would be negative x cubed plus x. And that does equal, when I plugged in negative x for all of that, right? This is equal to that. So since that is the case, we would say that this is an odd function. Okay, question. So how do we do it if we look at one graphically, right? So remember, when we're talking about an even function, our even functions are symmetric with respect to the y. So if I fold my y, so just think if I took this line and laid it on top of this line, right? And I folded it right on the crease of my y-axis, you will see that all of this is a mirror of all of this, right? And since that is the case, we would say that this here is an even function. Okay? Question. Now for this next one, if you look at this, we kind of look at it here and we want to fold it on our, actually we'll fold it on this fold of the origin, right? If you fold it on the origin, think of it, it's hard to visualize the origin because you kind of have to fold the paper in half, but like you're laying it down. So essentially, this would fold and lay right on top of this. This point would lay right on top of this. This point would lay right on top of this because it's with respect to the origin, we have this mapping here. And so this right here would be said to be one of those odd functions because we could fold it in a way on the origin that all of the pieces of one lay over. So if we think of it as if we took like this corner and mapped it up with this corner and how those pieces might lay together. Okay. Question. So there was question if you could stop. So for the exam, you'll need to show all three of them, right? You'll need to show that it is either even, odd, or neither, but you'll need to show it, you'll need to show, yeah, so for even for symmetric, you have to show all three. For even or odd, once you've determined it's even, you don't have to test if it's odd because it can only be one or the other. It cannot be both. Okay. And how would not odd look or not something else look? It could be, I mean, there's more graphs that are not odd or even than are of them, but it could be something just like this, right? You could see this shape is not also on that side. No matter how you fold it on the x-axis, the y-axis, the origin, you're not going to get symmetry. Okay. Good question. Any other questions? All right, so now we're going to look at evaluating some equations. This is what we call piecewise functions, and well, they're graphs of piecewise. And so for this one, it wants us to evaluate for these values that we were given. For this first one, we want to evaluate when x is equal to -1, 5, and 0. But we have this piecewise function here, so we have to determine which equation are we actually going to use. We can also let our graphical representation over here to the right help us on that problem, okay? So for the first one, we're looking at x equal to -1. So here's where x is equal to -1. And we can see graphically that that occurs at this point where y is equal to 2, okay? Now, if I did not have this graph here, I would look at these here, and where is x, we're looking at x equal to -1, so it fits actually in this equation here, right? Because this one right here is for all x's less than 0. Well, -1 is less than 0. So we would have said here, we would have said -1 squared plus 1, right? And that gives me 1 plus 1, which is equal to 2. So if I had not been able to graphically look at this and determine that it was a 2, I could have used my piecewise functions to help determine what that value is. Okay. So when I want to look at 5, I can say this one right here is 5 because that's for all values greater than or equal to 0. So I would use equation x minus 1. Well, my x in this case is 5, so 5 minus 1 equals 4. So let's go over to our graph over here at 5 and see if that's correct. So here we are at 5. So we're looking at this x value right here. And when I do that, I look at this point here, and that is, in fact, where my value y equals to 4. Okay? Question. All right, and so for the last one, the 0, because this has equal to, greater than, or equal to 0, we'll use this one here again. And so we have 0 minus 1 equals -1. So when we come in here and we look at this point here, we have the solid dot right here to show me that it has equality, right? And so we can see that, yes, indeed, that is a value of -1. Okay. Question.
I have a question.
Yeah, go ahead.
So, what if that other dot, the one that's white, what if it was filled? Would it have two answers then?
So remember, if something is a function, it has to pass the vertical line test. So both of these cannot be solid because then it would not be a function.
Okay, I remember that. Okay, that makes sense. Thank you.
Very great question, though. Really good question. Thank you for asking that. Okay, any other questions? So here is another graph, and I drew the equations on this graph over here for you to see, okay? So you see the blue one I've underlined, the blue graph, right? That's our x squared plus 3. Quick, we could have done this here in class because we know that the y squared typically starts out like this, right? But for this problem, it was our x squared with a vertical increase, a vertical shift up 3 units. So you could see we went up 3 units, and that's why our graph is there, okay? When we have just like the green one where it just says 7, that means that's a solid line. No matter what value I put in for x, my y is always going to be just 7. Okay? And then my red equation, it's saying that we have 2x minus 1. So if I plot, I could go down here. I could plot a point at -1. That's where it's my y-intercept. And then using rise over run with my slope, I can rise 2 units, run 1, and here's my next spot, and that creates my line here. So what I want to do here is we're going to scratch off the part of the graph that we're not using based on this graphic here. Okay, so I'm going to use my black pen here. So for the blue one, it's only for values of x less than 2. Okay, so here's x equal to 2. It's going to have a hollow dot here and then none of this. Okay, because it's only good for x values negative or from 2 or less. Okay, because remember, if it's a function, we can only be like, so right now, this doesn't pass the vertical line test, right? Because it crosses in multiple places. Look here at this, that it crosses in 3 places, right? So we have to determine which part of the graph is applicable based on our piecewise function here on the left. So for the 7, it's only good for x, x is greater than or equal to 2. So I'm going to undo this and go in blue. So blue is hollow here, and this part of the graph, it doesn't exist. Now let's go in green. Green, it's equality here, so this gets the green dot. It is at 2, and it's also a solid dot at 4, and that's it. So none of this part of the graph counts, and none of this part of the graph counts. Okay, so the green is only that space right there. Any questions so far? Okay, and then for the red one, it's only greater than 4. So we have a hollow dot at 4 and then everything greater than that. So none of this counts. Okay, so ultimately, we're really just looking at that as a solution. Okay. And so when we look at this, we need to determine what our values are, right? So when I look at x equal to 1, well, x equals to 1, my value then is what? Here's where x equals to 1. Okay. And we know we're using that top equation. So we have x squared plus 3. That is 1 squared plus 3. So that's 1 plus 3. That is 4. and we can check here and see that's 1, 2, 3. That point right there is 4. Okay, right there. Question. 3 falls in this line right here. So when x equals 3, that's this point right here. And we can see that our graph is just simply y equal to 7. When it's 4, when x is equal to 4, we're right here. And again, our graph just equals 7. Okay, when it's equal to 5, we have 2 times 5 minus 1. That is 10 minus 1 equals 9. So let's come over here when we're at 5. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, question. All right, so now let's look at graphing another piecewise function. So in this case, we have y equals 1/2 x plus 1, okay? And that's going to be what are our x values and our y values. Our x's have to be less than 2. So we'll get a hollow at 2 and then solid dots for everything else. So let's just do -2, 0, and +2. So when I plug in -2, I get -2 times 1/2 is -1. -1 plus 1 is 0. If I plug 0 in there, I get 1. If I plug 2 in there, I get a 2. Okay, so we can come plot those on our graph. So we have x equal to -2, our y is equal to 0. That is good. This one here, though, we have to remember this is hollow because there's no equality. Okay, so it can't equal 2, you could just get really close to it. So we have 0 and 1, and then at +2, we're up here at 2, and we have to put that hollow dot. And so then this is what our graph would look like for the first equation. Okay? Any questions? So for our second one, we have y equals -x minus 1. So what 3 points do we want to plot here? This is when y is greater than or equal to 2. So let's just do 2, 3, and 4. So when I plug 2 in here, I get -2 minus 1. That's going to give me -3. This one right here is going to be a solid dot because of the equality. When I plug 3 in there, I get -4. And when I plug 4, I get -5. So I come over here and I have +2 as my x, -1, 2, 3. Remember, I get to go solid. And then at 3, I'm at 4, -4. And at 4, I am down here at -5. And so this is what our graph would look like there. Okay, so that's how we graph those piecewise functions. Okay, question. Okay, so here's another example of these graphs. So for the first one, it's a constant. So no matter what value x is, my y is going to be -1, at least up to 0. Okay, so x equal to 0, My y is -1, so I'm going to just put a hollow here. And it's -1 all the way across. Okay? Does everybody see how I came up with that?
Can you repeat that one more time, please?
Yes. So because of the inequality, it's saying for all values less than 0, so for all x values less than 0, my y is just 1. There's no x component to it. Okay? And then whenever, let's look at the next one, we're going to look at my x values from 0. So here's 0. It includes it, so it would be solid. And up to my x values equal to 2, it again will be solid. Okay? So I could plug those into the equation. So at 0, I plug that in and it equals -1, right? 0 minus 1 is -1. Let's plug in 2. 2 minus 1 is +1. So I can go up here to, it's a +1. It's also hollow because of the equalities. Okay? So I can just create a link between those two. That takes care of that graph. And then for the last one, there's no equality, so that's 2. So whatever value this ends up being, it's going to be hollow, right? And so if I plug 2 into here, I get -2 times 2 plus 6. That's -4 plus 6. So that is equal to +2. So it will be 2, 2, but I'll get a hollow. So I have, here's 2, 1, 2. I've got a hollow dot up here, right? And now I can determine using, that's a point. And so I can use rise over run to get my slope. Because it's negative, we're going to drop 2. So we go 1, 2. And then we're going to run 1 unit because it's rise over run. So it's 2 over 1. And then this graph would go off like this. You could also build the table if you're not comfortable using rise over run and such. You could build the table like we did in the previous example to build a table to help you graph that out.
Excuse me, can you actually go up for like 2 seconds? I want to look at it, so I just want to take a picture of it real quick so I can, like to the previous one. Thank you. Give me 2 seconds. All right, I took a picture. Thank you.
Yep, and you know I post these after class in our modules as well.
Yes. Thank you, ma'am.
Uh-huh. All right, any other questions? All right. So this is everybody's favorite kind of problems, right? You all love word problems. And so really they can seem overwhelming and daunting, but honestly, if you just kind of walk through it, take it a little bit at a time, you know, and try to understand it, hopefully you can make a little more sense of it. So let's just dissect this into the pieces, right? So first of all, it says we get a new job offer in sales, which promises a base salary of $3,000 a month. Okay. Once you reach $50,000 in sales, then you're going to earn your base salary plus 4.3% commission on any sales over $50,000. And we want to write a piecewise function here to help us determine this, right? So when you're under $50,000 in sales, you only get your salary, okay? So we're looking at some function s of x, our salary, right? And we know that we're going to have two equations. So if I have 0 to $50,000 in sales, then I just get $3,000. Okay. However, if X is greater than or equal to $50,000, right? Meaning I sold more than $50,000, then I'm going to get my salary of $3,000 plus I'm going to scoot these over because I'm going to get some commission of 43%. So that's 4.3% times X minus $50,000. Okay. And so what that means is that if I sold, let's say $60,000 worth of things, then I'm going to get my $3,000 plus 4.3% of the other $10,000, right? I don't get 4.3% on the whole $60,000 of things I sold. It's only on the things I sold above $50,000. Okay? Questions? And so you guys will not have a word problem typically on exams, but you might see them in your homework. And so that's why I just kind of go over an example of that with you here for in class. Okay. All right, so next we want to talk about when is our graph increasing, when is our graph decreasing, when is our graph constant. So basically, if you think about it, if you're going from left to right, as your X values increase, if your Y value also increases across that interval, that means your graph is increasing. But as my X goes from left to right, if my Y value decreases, then that is when I will see my graph decreasing. And then if I'm held constant, right, like those Y equals 7, no matter what my X value is, my graph is always that constant value. That's when we would say a graph is constant. Okay. So using that idea, we can look at a couple of graphs here and determine when is the graph increasing, when is it decreasing, and when is it constant. Okay. And so here we have increasing. So I could see when I go from left to right, I'm increasing here and I'm increasing here, right? So I could come over here and say that this graph is increasing from negative infinity to 1, 2 to 2 to negative 2. And it's increasing from 1, 2, here's positive 2 to positive infinity. And those are for X values, not Y values, okay? We can also look at where is our graph decreasing. You can see that the graph decreases on this interval right here. And so that is from 0 to 2. So my X value, when X is 0, it decreases all the way until X is equal to 2. And then finally, where are we constant? And our graph is constant right here in this piece. And that remains constant from negative 2 to 0. And that is what we have. Okay. Questions? Okay. So I'm going to give you guys about a minute to see if you can determine which intervals are increasing, decreasing, and constant on the graph here to the right, and then we'll go over it together as a class just to make sure that you guys are understanding. All right, so when we look at this graph, we can actually see that at no point in time does this graph increase, right? So this one, it never increases, and it never stays constant, okay? Which means that we are constantly, you can see we're decreasing in this piece, we're slightly decreasing here, and we're decreasing even more here. So in this graph, we're actually decreasing across it always. So it's from negative infinity to positive infinity. Okay, questions?
Why is it decreasing? Like when the arrow is all the way up, because it's negative x.
Yeah, so this
Oh, okay.
arrow here is just saying that that'll go on for infinity. And this here is saying it'll also go on for infinity. Why it's decreasing is because if I'm at x is -5 and x is -3, here my y is 2 and my y is 5, right? So I have 5, +5, but as I get larger in my x value to move over here to the -3, my y value decreases. So it
Got it.
falls
Thank you.
along this methodology here. And it does that for each of those 3 intervals. So even though they're decreasing at different rates, they're all still decreasing. You could think about it also like if you're driving a car along and then you get here and you have to climb this hill, that means you're positive, right? You're going up. But if you're driving here and you hit this one here, you start going down, you're decreasing, you're going downhill. It's kind of the same thought over here, right? You hit the graph, you have to go down. You hit it here, you're still going down. You hit the graph, you're still going down, just at a different rate. Okay? All right. So the last thought for this evening is really just the idea of relative maximums and relative minimums. Okay? And so with the relative maximum, we're just saying that in the vicinity near x, there's some value that makes that the highest point, and vice versa for the relative minimum. So there's some area near that makes it the lowest point. Okay, it doesn't mean it's the absolute, it just means relative. It just means that we could have a maximum or a minimum. We could have more than one maximum and more than one minimum. So long you can only have one absolute, but we're not covering that terminology right now, but that's really the idea behind that. Okay, so when I look at this first graph and I want to determine what is the lowest or the smallest point that I can see that isn't the arrows, right? It would be this point right here. And that occurs when x is -2. So I have a minimum at the point -2, -1. Okay. Similarly, I have a maximum, that's the highest point, that's a maximum, and that occurs at the point 0, 1. Okay. Questions? All right, so this next graph, you can see we have a low point here and a low point here, right? But we also have a high point up here. And so if I wanted to look at my minimums, I'm going to have a minimum at -1, -2. And I'll have a minimum here at 4, 0. Okay. Then I'll have that maximum at that point 1, 2, 1, 2, 3. So that is x equal to y equal to 3. Okay, questions? All right, so for this last graph over here, we don't actually, this is an inflection point. It's not actually, you don't have a concave up or concave down. It's an inflection point. So it's actually not, this one has no max and it has no minimum. And as I said, it has an inflection point instead. And that inflection point just means that the graph is going increasing and it smoothly transitions across there and it never actually decreases. So since the whole entire thing is increasing, there's no transition from, so like if you look at this graph here, I'm decreasing and I'm decreasing, right? And then on the other side, I'm increasing and I'm increasing, right? So you have a maximum or a minimum at the transition from a decrease to an increase. But for this one, we're increasing the whole way. So there's no maximum or minimum because it's all an increase. Okay? Questions? All right, so that takes us to the end of section 1.7. I think what I'd like to do is give you guys a 5-minute break, so that you can stretch your legs, get a drink of water, and then we'll come back at 7:40, and we will so we'll come back at 7:40, and we will look at the next section. Then we'll probably take another small break before our exam review. Okay. All right, it is 7:40, so let's go ahead and keep moving through the material. So now we're going to cover section 1.8. In this section, we're going to start looking at the algebra of functions. And so up at the top, what you see is if I take one function and add it to another function, it's the same as if I added f and g and then multiplied x. It's the same as substituting in whatever my x value is into the f function and then plugging that into the g function, adding them together. It works the same with subtraction, multiplication, and division, so long as my function that's on the bottom is not equal to 0 if I'm doing division, okay? And so here we're given f of x, g of x, h of x. We're given 3 functions, and we want to evaluate these functions for the given thing that we're given down here. So for this first one, let's look at f of -3, okay? And so when we do that, that is going to be, so my f function, that's this one. So that is -3 squared minus 3 times -3 plus 1. Okay? So that's going to give me 9 minus -3 times -3 is +9 plus 1. So that is 9 plus 9 plus 1, which is 19. So when I evaluate my f function at -3, I get a result of 19. Okay? Questions? So let's look at our g function then, evaluated at 4. So that's going to be the square root of 8 minus 4. So that equals the square root of 4. So that is equal to plus or minus 2, right? So remember, anytime you take the square root of a number, it's both the positive and the negative of that number. There are cases where we'll disregard the negative values because maybe we're just looking at one particular area of the graph. Okay. All right. And then our next problem, we have our f function is a plus 1. So that's telling me everywhere I have an x in my f function, I'm going to substitute in a plus 1. So this is x is x squared, so that's a plus 1 squared minus 3 times a plus 1 plus 1, okay? And so a plus 1 times a plus 1, that's going to give me a squared plus 2a plus 1. And then -3 times a is -3a. -3 plus times plus 1 is a -3. And then plus that 1 out there on the end. And now we just need to simplify. And that is a squared. We have a positive 2a and a negative 1a. So that's a negative a. And then we have a positive 1 plus 1 minus 3. So that's going to give me a negative 1 here. So when I evaluate my f function at a plus 1, it simplifies and reduces down to a squared minus a minus 1. Okay, question. Okay. Now let's evaluate my g function at 10. Okay, so we have the square root of 8 minus 10. This gives me the square root of -2. We can't, everything in the radical underneath that denominator has to be greater than or equal to 0. Otherwise, it's imaginary, or we will call that undefined. Okay, so it's almost like coming up with a division by 0. So the radical, it must be greater than or equal to 0. Okay? Question. All right, so the next one here, we're going to look at our f function minus our g function, so we can evaluate those individually. So that is, we could say our f function, we'll put f of -8 minus g of -8. Okay, so that is -8 squared minus 3 times -8 plus 1 minus the square root of 8 minus 8. Well, actually, it's 8 minus the -8. Okay? So this simplifies to 16 plus 24 plus 1 minus the square root of 8 plus 8 is 16. In this case, we can just do the positive because it's the radical. We'll just look at the positive of it because this technically, right, could be positive or -4. So that would be 16 plus 24 plus 1 minus 4. Okay. And so that's going to give us a value of I think I wrote down the wrong answer. This is 8 plus 8 is 16, so that's 4. Yeah, minus 4 out there. So we have 40, 36, 37. Yeah. On the work I scratched out ahead of time, I had a different value. So when we do this, oh, you know why? Because 8 times 8 is 64, not 16. That's why I have a different value. Sorry. So this should be 85. Sorry about that. All right. Yes, thank you in the chat. All right. So any questions on that? So you can see we didn't have to add or subtract G from F before we could do the work. We can just do that substitution and then subtract the end value. Okay. So what about if H is equal to -1? Okay. So our H, we have this 2 divided by -1 plus 1. So that is 2 over 0, which would be undefined because we cannot divide by 0. Okay? Questions? Okay, so what if we want to write this in interval notation, right? So if I want to know what is my domain, remember domain is what values can x be. And so if I want to do that and determine what my domain is here, how could we do that? And so here I have r minus t. So my r function is x squared plus 3. My r, and I want to minus my t, which is x plus 4. So that is x squared plus 3 minus x minus 4. And that simplifies to x squared minus x minus 1. Okay. So because I didn't have an actual value to substitute in for my x, I had to leave it in equation form and just simplify it the best that I could. But the problem here wants to know, what is our domain? What values can x be? And there's no restriction here, right? I could go from negative infinity to positive infinity. And there's no restriction on my x value. So the domain is going to be all real numbers, or negative infinity to positive infinity. Okay. Question. So the next one, we're looking at r divided by t. So my r equation, that is x squared plus 3 divided by t, which is x plus 4. Okay. So in this, I am going to have a domain restriction, right? So my denominator, so x plus 4 cannot equal 0. So that means that x cannot equal -4, right? If I minus 4 from both sides. Therefore, my domain is going to be negative infinity to -4 with the parentheses. Then it'll pick back up and go from -4 to positive infinity. So if I was graphing this, I would have a hollow dot on -4, because that would signify that I can be everything leading up to, but not including that -4, because if it's -4, it makes my entire graph undefined. Okay? Question. Okay, the last problem on this page or this slide is s times t. So my s function is 2 over x times my t function, which is x plus 4. So there's a couple of ways we could write this. So that's the same as x plus 4 over 1. So we can multiply 2 and we get 2x plus 8 over x. Okay. So similarly, we know that x cannot equal 0. So when I'm looking at my domain, it can be everything but 0. So I could go from negative infinity to 0, and I can go from 0 to positive infinity. Okay. Questions? All right. So now let's talk about, this is what we call the difference quotient. It's, if any of you plan on going on into calculus, like from this class to pre-calc 2 to calculus, or this class just to applied calculus, it's important that you pay attention to this here, because I promise you, you will see it again when it comes to calculus. Because this is really a lot about where limits and such come from. We're not going to get into that topic in this class. Just know that this is not something that you want to just brush off if you intend to take higher maths in the future. Okay. So it's really just talking about the average rate of change. So typically we're used to looking at that red line, right? That says secant line. And so when we're talking about a slope of a line, we look at that secant line, and we do it looking at that, right? It's a straight line. The rate of change is the same from one point to the next, and it's constant. But if you look at the blue line, we aren't, right? If I wanted to calculate the slope of that line, it would be much more difficult, because I don't have the tools to do so at this point. So what if I asked you, we're going to say we're looking at some value h, right? I mean, some value x, and I want to look at some other value down the road, and we'll call that h. Okay. So the distance between x and x plus h is h. And so if I want to find my function, my slope, remember slope is really just y2 minus y1 over x2 minus x1. Slope is the letter M, right? If you remember back from high school algebra days. And it really just signifies the change in my y values divided by the change in my x values. Well, when we're looking at it in terms of, and we're calling it x plus h instead of like x1 and x2, we can still apply the same logic and theory, okay? And so it simplifies down to this f of x plus h minus f of x divided by h, and that's called our difference quotient, okay? So if I have this function here, 5x minus 2, and I want to substitute in everywhere I see an x, I'm going to substitute in x plus h, right? And then I'm going to do the whole equation over again and substitute in just x and put it all over h, okay? So that equals 5x plus h minus 2, okay? So let's do that just in purple. Then we're going to minus the entire equation, which is 5x minus 2. And then we're going to put it over h. Does everybody see how that transpired? Okay. So now let's just plug this away and simplify it. So this gives me 5x plus 5h minus 2 minus 5x plus 2 divided by h. Okay. So I have a positive 5x and a minus 5x. Those cancel. I have a negative 2 and a positive 2. Those cancel. And it leaves me with 5h over h. Oh, look, our h's cancel. And it leaves me with a 5. Okay. So if we were doing this in terms of calculus, we would say that the limit of this function is equal to 5. Okay. But that's not quite, like, that's one small example. I have a bigger example where we use a little bit bigger equation than just 5x minus 2. Do you guys have any questions on this before we move on to that example? Okay. So first of all, let's look at 5x plus h. If I'm looking at just 5x plus h, then that's going to give me x plus h squared minus 3 times x plus h plus 8. So all I've done is substitute x plus h everywhere in my equation that I see an h. Okay. This will simplify to x squared plus 2xh plus h squared minus 3x minus 3h plus 8. Okay. So now I already know that my equation itself, I'll put that here, my equation itself, the f of x, was just x squared minus 3x plus 8, right? So when we put it all together with our f of, let's do f of x plus h minus f of x divided by h. We get this piece here. We'll copy it. Okay. Minus this piece here. we're gonna have minus, but it's the whole thing, so that negative has to get distributed to all three pieces. And then all of that divided by our h. Okay, so when we do this, this becomes negative x squared plus 3x minus 8. Okay. And so now we can say, well, I have a positive x squared and a negative x squared. I have a negative 3 and a positive 3. I have a negative 8 and a positive 8. And then that's going to simplify down to 2xh plus h squared minus 3h divided by 8. I can factor an h out of each of the terms in the numerator. If I factor an h out, it leaves me with 2x plus h minus 3 divided by h. Those h's will now cancel, and that leaves me with 2x plus h minus 3 as the solution of our difference quotient there. Okay? Question. And again, in calculus, you'll take that a little bit further, but for the purpose of this class, that's as far as we go. Okay? All right, so let's talk about the composition of functions. So you would read this here as f of g, okay? And really all that means is it says everywhere I see my f function, I'm going to substitute in my entire g function, okay? And so you could see here that f of g of x is really substituting my entire g function into my f function. Okay, if it was g of f of x, I would substitute my entire f function into my g function. And we'll see that in this example here. Okay, so let's say, let's make this one blue and this one not blue. Let's make it green. Okay, so that we can see how we're substituting these things in. In case you guys haven't picked up yet, I like to be very visually representative of how I lay out the work, because I think that for many of you that you will find that to be helpful. Okay. All right. So this first one is f of g of x. So really that's telling me that everywhere I see my f function, I'm going to substitute in my entire g function. Okay, so another way of saying that is f of, well, my g function is 5x plus 4. Okay, so you're going to plug in that whole equation into your blue function, right? So our blue function is x squared. I'm going to leave it here. X squared minus 3 times x plus 1, right? And this is my x squared. We're plugging in everywhere we see x, we're plugging in our entire g function. Okay? So this gives me 25x squared plus 40x plus 16 minus 15x minus 12 plus 1. Okay? And when we simplify this down, we get 25x squared plus 25x plus 5. So that composition of that function is 25x squared plus 25x plus 5. Question. Where did the 40 come from? The 40, so you have to do 5x plus 4 times 5x plus 4. And so when you do the FOIL method, it simplifies because you have 5 times here is 20x, and the innards you have 4 times 5 is also 20x. When you add those together, you get 40x. Does that help? Perfect. Let's just slide this over here. We'll make it in a different color. Make it a little bit smaller. Okay. All right, so if we do the same, but now we're going to take our g function, and every time we see x, we're going to substitute in our whole f function. That would be this one here, where we are g of f of x, which is f of x squared minus 3x plus 1. And so in this case, when we see our g function, which is 5x, need a little more room, 5x plus 4, everywhere we see that we're going to plug that into here. Okay. Now we want to simplify, distributing that 5 to everything. We end up with 5x squared minus 15x plus 5 plus 4. Simplify that, and we get 5x squared minus 15x plus 9. Okay? Question. All right, so a couple of more examples. In this one, we're looking at f of g of x. So I'm not going to change the colors a lot. That slows us down a little bit. But you have the other examples to look color-wise. So this is really just going to be f of g of x, right? So we take 5, we're going to substitute our entire g function in here. We get the square root of 5x plus 5, but that's squared minus 1. Anytime you square a square root, they cancel each other out. So that leaves me with 5x plus 5 minus 1. So that's 25x plus 25 minus 1. And it'll finally simplify 25x minus 24. Okay, question. Now when we do the opposite and we do g of f of x, so we're going to plug our f function into our g function. So our g function is this 5 times our f function. So this is 5x squared minus 1 plus 5. So when we simplify this, we get the square root of 5 times 5 is 25x squared minus 5 plus 5. Those cancel out with each other, and it leaves us with the square root of 25x squared. And so that is the square root of 25 is 5. And the square root of x, we're going to just put an absolute value of x, because remember, it could be -2. It could be a negative x times negative x, or positive x times positive x. So we'll just, and when we take a square root of a squared variable, we just bring that out into an absolute value sign. Okay. Question. Okay. Let's see. Let me go ahead and do one more this set of examples, and then on the next slide, I'll give you guys a few minutes to work through some examples and see if you're understanding it, okay? And give you the opportunity to ask questions if you don't. So for this first one, we're looking at f of g of 9, right? And so this one, we're looking at f of g of 9, okay? So the first thing, let's just evaluate g of 9. G of 9 is going to be 2 times 9 minus 8, which is equal to 18 minus 8, so it's 10, okay? Now we're going to evaluate f at 10. Right? Because we're substituting that into here because we were looking at f of g of 9. Well, g of 9 is 10, so we're looking for f of 10. Does that make sense? Okay. So that's going to be our f function is 3 over x minus 4. So that is 3 over 6, which is 1/2. And that would be your final solution for this problem because it was asking us for f of 10. Or really, it was f of g of 9, which is 10. Okay? Question. So for this other one, we're looking at g of f of 6. Okay? So first, let's determine what is f of 6. F of 6 is 3 divided by 6 minus 4, and that is 3 over 2. So now we want to evaluate g of 3 over 2 because we're just plugging that into our function here. And so that is 2 times 3 over 2 minus 8. So that is 3 minus 8, which is negative 5. Okay, question? All right, so for this one, I'm asking you to find f of g of x and tell me what the domain is. Okay, at least take a minute to try and figure out f of g of x, and then we can talk through the domain together. Okay, I'll give you guys a couple of minutes to do that. All right. Does anybody want to share what they were able to come up with? So for this problem, we want to do f of g of x, right? So that is, we're going to plug our g function into our f function. So f of g of x is really saying this is my f function and I'm plugging my g function into it, okay? So my f function, which is 3x plus 2, but I need to substitute in my g function for my x, okay? So this is going to give me 3 over 3x, which is the same as 1 over x, okay? Therefore, when I'm looking at my domain, I know that x cannot equal 0, okay? But I can't forget that up here, I also have a restriction that says x cannot equal -2 because it'll make my original function undefined as well. So I have two restrictions on this problem for my domain. So I would say here then that my domain is -∞ to -2, and then -2 to 0, and 0 to positive infinity. Okay, question.
How did you get -2 out of x plus 2?
Because x plus 2 cannot equal 0. So if I minus 2 from both sides, I get that x cannot equal -2.
Okay.
I'll change it to that color to kind of help if you refer back to these notes. Okay. Any other questions? All right, so for this next one, we're given the square root of 3x minus 7, and we're asked to find two functions, f and g, such that when I make the composition, I get this h function, okay? And so if you think about it, we can say this is all the innards, right? So if I had the square root of x, and I had 3x minus 7 as my two functions, now I just have to determine which one is f and which one is g. This is saying that h of x is equal to f of g of x, which means it is f of g of x. So that's telling me that my g function is plugged into my f function. Therefore, my f function has to be the parent, and my g function is what was substituted into. Okay? Question. So I'll give you guys a minute to look at this problem and see if you can decompose it and tell me what is my f function and what is my g function. Anyone know? So if we focus in on this piece right here, right? That looks like this could be substituted in for something, right? So we have this x plus 1 is substituted in. If that's substituted in for x, then the rest of it could be x cubed plus 8, right? And so again, we're looking at f of g of x. So that is f of g of x. So my g function is substituted into my f function. So this looks like it's g, and this looks like it would be our f. So this would be my g of x, and this would be my f of x. Okay, question. I don't know why sometimes the parentheses fall off when I paste the values in here, but there we go. All right, so for this problem, we're looking to see if I have my f function minus my g function, what is that? So this is saying if I have my f evaluated at 3 minus g evaluated at 3, so my f function is blue. If I go to x equal to 3, here's 1, 2, 3. So it's this line right here. At that, my blue function is 1, 2, 3, a value of 4, minus my g at this point is here at 3. So 4 minus 3 is equal to 1. So we can get that from a graphical representation. We don't have to just plug it into a formula to see what that is. Okay. Let's look at the next one. So the next one is g. That is g of -2 divided by f of -2. So where is my g of so -2 is right here. And g is -1, -2, -3, -4. And f is +2. When I do the simplification, that is -2. Let me okay. Question. So g of f of 1, that is saying g of f of 1. Okay. So f of 1. So here's 1 and f, that equals 2. Right? So now we're looking at g of 2. We come over here, g of 2, that's this point right here, and that looks to be the value of 4. Okay, questions? F of g of -3, so that is f of g of -3. So what is g of -3? We go -1, 2, 3. Here's that. G is this value here, which is -4. So that is really f of -4. So here's -1, -2, -3, -4. And my f function is -2. Okay, question. So the last one here is f of -3. So that is saying f of -3. So what is -3, -1, -2, -3? My f value here is 0. Okay, so it equals 0. So that is f of 0. So we come back up here and we look at 0. What is my f value? My f value, or the value of my f function, is equal to 2. Okay? Question. So we just have one more problem left of this unit, and it is a word problem. Okay, so a party balloon is filled with helium. As the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. We want to write a function that represents the radius of the balloon. We'll call that r of t after some amount of t seconds. Okay, so our r of t is equal to, remember, it was 3 inches per second, and our time is measured in seconds, so it'll be just 3 times our time. Okay. For the second one, we want to write a function that expresses volume. Well, volume's equation is just 4/3 pi times r squared. So we would just say this is our volume with respect to r is equal to 4/3 pi r cubed. And so that is just our standard volume equation. I don't expect you guys to memorize this format or the volume of, if you come across one of those in your homework, they will give you the formula and you don't need to have that memorized. Okay. Now, if I want to do my velocity or my v of r, then, and we can kind of interpret the meaning of that, but so v of r of t is going to be v of r of t, right? We're substituting our r function into our v function. And that is 4/3 pi. My r is 3t, and then that's cubed. So this is going to be 4/3 pi r cubed. So 3 cubed is 9, and t cubed is t cubed. Okay. So this is actually, I did this squared. So it's 3 times 3 is 9 times 3 is 27. Okay. And then I can simplify. 3 cancels 1 time, 3 goes into here 9 times. 4 times 9 is 36. And we have 36 pi t cubed. Okay. And so what does this tell me? It tells me that what the volume of the balloon is at time t. So if I plugged in there time 1 second after I started blowing it up, I could tell how much air is in the balloon. If it's 10 seconds after I started blowing the balloon up, then when I substitute in 10 for t, then that would give me the volume of air in that balloon. Okay, question. Now let's say we're going to evaluate this at 2. We don't have to do the v of r again. We already have the formula. So we could just take our 36 pi evaluated at 2 cubed, right? And that is 288 pi, or it's approximately 904.32 inches cubed. Okay. And so what does that mean? That means that after just 2 seconds, the volume of the balloon is approximately 904 cubic inches. Okay? Question. All right, so let's take another 5-minute break. Or let's take 10 minutes this time. So let's come back at 8:40, and then we will go over the exam. I'll pull up the assignments that you have in Canvas to show you where that it is located. And we'll do all of that starting at 8:40 in 10 minutes. Okay. All right, it is 8:40, so let's go ahead and take a look and we'll discuss the expectations of the exam and what you could expect to see on exam day and so forth, okay? So as I mentioned, let me go ahead and screen share briefly from my actual laptop. So, okay. So if you come to the assignment tab and you scroll down to the exam section, right? So remember, you have all of the homeworks. You can scroll past them or you can collapse it, right? And you can come to the exams here and you'll see exam 1, the one with the rocket. That's where you're going to actually go to get assigned your question. Okay, you'll do them on a piece of paper. Nice legible written paper because you're going to take screenshots or scan those in and upload those. So you're going to take the exam. When you're done, you hit submit, you take your pictures, and then you come over here where it says exam 1. It's locked right now because it doesn't open until the actual exam day. But that is where you will upload your assignment. So I'm going to come up over here back under our practice uploading because it looks exactly the same. And so you'll see something here and excuse me, it tells you you have to name your file, right? So say you take 10 pictures. I do not want you to upload 10 individual pictures. I want you to put it all into one file, save it with your last name, your first name, and you can even just put exam 1, exam 2, exam 3, final, whatever. But it is very important that you have your last name and your first name because I download your work and I grade it offline and then I have to submit it back. I have to upload it back. If you don't put your name on your stuff, then you're going to get a point deduction because then I have to hunt you down, figure out which exam belongs to who, because you didn't follow the directions and save with the correct naming convention. So most importantly, if it was my exam, it would just say Hatch, Sandra, exam 1, or Hatch. At least Hatch needs to be the very first thing because that is how I'm going to identify to be able to put the grade in the grade book, right? So again, don't submit 4 or 5 different pages of pictures. I want you to put them all in one. And so I've graded a few of the file uploads. And so for those of you who put them in as 2 pictures, if I've graded yours, you'll notice you got a point deduction. And I allow you the opportunity to come back and resubmit the proper way to put it in where you're using your last name. I didn't, enforce the last name on the homework, but it should be your last name. And, but it has to be in one page, one document. It could be a Word document, it can be a PDF, preferably a PDF, but if you can't get it into a PDF, and you can get it into a Word document, I would accept that as well. Okay. Any questions on the expectation of uploading the work? Again, if you want to practice uploading some more, you can do so in the assignments. If it is locked and you're not able to, shoot me an email and I will go in and put you some more attempts in there. Okay? All right. Any questions? Is it possible to retake Alex assignments? The Alex assignments are closed. They should not be closed. They're open. They should be open all the way till the end of the semester. If you send me an email after class, I will look into that just to make sure that they're not closed. Because remember, in Alex, once you've answered one question, it moves you to the next assignment. But remember, I showed you how we can go on the 3 lines, click on that, and then you want to select on Learn. And then from the little drop down, you can select section 1.3 or whatever. Even if it pushed you out to chapter 2 or whatever, you can go back and select the one you want to work on. Okay. So, and then there's also a tutorial. Let's go over here to our assignment or our announcements. And this Alex tutorial, if you click on that, this also walks you through how to go to the 3 lines. You want to learn, choose this little drop down arrow. Then you can choose from here the different assignments that you can choose from. And so even if it's pushed you down here in a different chapter, you can come up here and click which one you're wanting to work on. Once you've selected that, then across here, you can scroll right here to get more problems that you can work on for that. Okay. Does that help? All right. Awesome. Okay, let me stop sharing my laptop and let's go back to the tablet and our whiteboard so that we can get on with our review. Okay, so the exam will open at midnight and close at 11:59 p.m. next Monday. That is the 19th. So February 19th, no class, just an exam. There will be 20 questions. It'll cover only the material from the 4 sections of chapter 1. You'll have 90 minutes to complete the exam. That does not include the time to take the pictures, upload the work. You have 90 minutes to take the exam, it closes. Then you have an additional 15 minutes to take your pictures, upload the work into Canvas. Okay. Remember, you have to show your work. You can't just put an answer. If you just put an answer, you will not receive any credit unless when we're going through the review, I say this doesn't have any work to show, then you're off the hook for showing work. Okay. Remember, you have to submit that work within 15 minutes of completing the exam so that you don't get a point penalty. Can you scroll up a bit of the page? This is the top of the page. Do you mean like to the bottom?
Yes, yes, thank you.
Uh-huh. All right, so, and then again, remember this piece of paper here, that's already out there in our modules, so you guys can look at it and review it. And also, if you want to take a picture of it right now, you could do that as well, whatever works best for you. What I will say is you could go in your textbook and you could find page 146. And from page 146, these are the problems that you should focus on. Okay, out of section 1.3. Out of section 1.6, page 193, these are the problems that you should focus on. Okay, and over the course of the next 45 minutes or so, I am going to work one example from each one of these 20 problems to kind of help you have just a little bit more stuff to practice, study, and such. Okay. Any questions so far?
Professor, is the exam is during the class? Yeah.
The exam is you could take it during our scheduled class time. But if it's more convenient for you to take it at 2 o'clock in the morning, you could take it at 2 o'clock in the morning, so long as it is on Monday, right? So maybe you have kids at home and they're noisy and you can't really take an exam at 6:30 at night. So maybe you want to take the test when they go to bed at 8:30. You could take the test at 8:30 p.m. You just have 90 minutes to complete it, 90 consecutive. So once you open it, your clock starts and you have 90 minutes.
Oh, okay. Thank you, Professor.
Professor, where can I find the textbook?
The textbook is in Alex. So you can review last week's video. We went over how to get to it, but I don't have Alex logged in on my computer, but just from memory, I will tell you, if you go to those, I was showing in that announcement, the 3 lines. If you click on the 3 lines, but instead of selecting learn, scroll down almost next to the bottom, it says textbook. And then it'll give you a digital copy of the textbook.
Okay, teacher, thank you.
Yes.
You're welcome. Any other questions before we get on with the review? I will also add that even if you guys come up with questions between now and, I would say Sunday night, feel free to shoot me an email and I will help you out as much as I can. If I can't help you via like just communicating back and forth from emailing, then I'll hop on. We'll come up with a time that's mutually beneficial to both of us, and we'll figure out a time that we can have a quick Zoom meeting so that I can help make sure that you're as prepared as you want to be for the exam. Okay. Just keep in mind that I do have a day job, so daytime hours are probably gonna be non-negotiable just because I'm not at a place where I could log into my computer to help. Okay. All right, so let's go on with this here. So for the first one, we're looking to determine if if this is a function or not. So if you remember, this would be one of the problems that does not require work, no work required. Okay. But you need to do the vertical line test, right? So you draw a vertical line and you can see that the graph is intersected more than one time. So this is not a function. Okay. Question. Okay, so for this next one, we want to evaluate the function. So we want to evaluate 5x squared minus 4x at -2. So this is h of -2 is equal to 5 times -2 squared minus 4 times -2. So that is 5 times -2 times -2 is 4. And -4 times -2 is +8. So this is 20 plus 8, which is 28. Okay. Then I would just ask that you circle box some sort of, hey, this is my answer, so I don't have to dig around for it. Okay. Question. Okay, so this next one, we want to determine x and y intercepts for the given equation. So remember, if we're looking for our x-intercept, we're going to set our equation equal to 0 and solve. So that's 0 equals x squared minus 12. We can add 12 to both sides, and that gives me x squared equals 12. Now I want to take the square root of both sides, and I get that x is equal to plus or minus, right? The square root of this. So I like to always break this down. This is 2 times 6. This is 2 times 3. And so for every 2, I get to pull 1 outside of the radical. So this is going to give me x is equal to plus or minus 2 square roots of 3. Okay. So if I'm looking for my x-intercepts, that means I have one at 2 square roots of 3 and y is 0. And I have another one at negative 2 square roots of 3 and 0. Okay, so those are my x-intercepts, but I also need to determine my y-intercept. And you remember the y-intercept is I just let x equal 0 in my equation. And so that's 0 squared minus 12, so that equals 12. So x is 0, y is 12. That is going to be my y, I mean not 12, negative 12. That is going to be my y-intercept. Okay, question. Okay, so for this next one, we want to determine what is the domain. Remember the domain, first of all, there's a couple of things here. I know that my denominator, so the cubed root of t minus 7 cannot equal 0, right? So how is that going to equal 0? That would equal 0 if the insides here were equal to 0. So that would be t minus 7 cannot equal 0. Or where does it equal 0, right? It equals 0 when I add 7 to both sides, and that gives me t equals 7. So if I look at it and think about it on a number line, if this is the number 7, it would be hollow. I cannot equal it, but I could be greater than it and I could be less than it. I just cannot be equal to it. Okay? But you say, hey, but we can't equal, this has to be greater than or equal to 0. It doesn't, because this is an odd number. If that was an even number, then we would have to have that where the t minus 7 was greater than 0. But since it's a cubed root, we don't have to have that. Okay. So when I'm looking at my domain, because that's what this problem is asking for, it can go from negative infinity to 7 and from 7 to positive infinity. Okay, question.
Teacher, could you please explain the domain again? I'm sorry, I didn't get it.
Yeah. So with the domain, that's just saying what values can our x be, right? And in this case, because we have that denominator where our denominator cannot equal 0, so what is going to make our denominator equal to 0, right? And that's going to happen if t minus 7 is equal to 0, then our denominator is equal to 0, right? So when I solve that, I get that t equals 7, right? So if I plug 7 in there, I get 7 minus 7 equals 0, and that's undefined. So my domain for this can be any number except 7. So that means I can go all the way out here to negative infinity, or I could go all the way out here to positive infinity. I just cannot be 7. That's why I have that hollow on 7. Okay. And so when I write that in interval notation, I do that by saying I can be anywhere from negative infinity up to 7, or I could be 7 all the way into positive infinity. Did that help?
Yes, teacher. God. Thank you.
Any other questions? Okay. So for this next one, we need to interpret this graph graphically. Okay. And so for the first one, we want to determine what is f of 0? Well, so what that's saying is, what is my y value when x equals 0? So I come here and my y value when x equals 0 is 0. Okay, does everybody see that? So this is saying when x equals 0, what is y? Okay. So when x equals 4, so we come out 1, 2, 3, 4. Here's x equal to 4. What is my y value? My y value in that case is 2. Okay. My domain, so that is my x value. So you can see x clearly stops right here, but it goes all the way to infinity. Okay. So my x value can be as small as -2, but it goes all the way to positive infinity. Remember, infinity always gets parentheses because you can't pinpoint an exact. And because that has a solid, -2 is part of the solution. So we can put a bracket on it to say -2 is included in that domain. Okay. If this had been a hollow dot, then that would have been a parenthesis saying that the -2 is not included in the domain. Okay. Question. The range, that is my my y values. So we could see we're as low as here and as high as here. So we're kind of, our range goes in between these two. So this is -1, 2, 3, 4. This is -4 all the way up to +2. So my range, it includes -4 and it includes +2. So we put brackets on both ends. Okay. Question. For this last one, it says all x for which f of x equals -4. So right here, really what you're saying is, what are the x values when y equals -4? Okay. So we go -4, that's this point right here. So what is this value and this value? And those x values are -2 and +2. Okay. Question.
I have a question.
Sure.
So how do you know when it's asking for x values or y values? So like for example, the first one, where it says like determine f of 0, how do you know we're not asking, or actually no, let's talk about the second one. How do you know they're not asking for like f
The
of
y value.
yeah.
Because our functions are what? F of x equals something, right? So this is f of, oh, that tells me x equals 4.
Oh, okay. So like for that very last one, because it says like it's asking for the x's, that's why we assume it's y.
Yep, because we also know that f of x is the same as saying y. They're interchangeable. So you could see this here as saying y equals -4. So where does y equal -4? Oh, it happens at x equal to -2 and x equal to +2.
Okay, thank you.
Yep, I hope that helped. Okay. All right, so now we're going to get into the transformations, right? So we have some transformations, and these you can just solve graphically. So again, these you must label your graphs on the exam, but no work is really necessary. Does that make sense? Because, well, what you could say here is you could circle this and you can say down 1 unit, right? That could be the work that you show, and then you just move everything down 1 unit, right? So all of this stuff gets moved down 1 unit, down 1 unit, down 1 unit. And that is that graph, that transformation is graph. Okay. You will have to graph this on the exam, yes. So if you don't have graph paper, it's really important that you label your graph, because if you don't label your graph, or you don't write down 1 unit, write 1 unit, you know what I mean? Then I can't tell if you knew what you were doing or not, if you just kind of put stuff on there without any label. Okay? All right, so this next one, this here, this -2, that tells me I am shifting right 2 units. So I shift everything to the right 2 units. 1, 2, 1, 2. I'm going to shift this one 2 units, this one 2 units, and our graph will look something like that. Okay? Question.
I have one about like the papers. So would you want us to do all the questions on the graph paper, or maybe like do most of the questions on the normal paper, and then whenever we have to graph, use the graph paper? Or you don't
If
have
you have plenty of graph paper, I am not opposed. I am indifferent. It doesn't matter to me, whatever you're most comfortable with.
Okay, got it. Thank you.
If you put it all on graph paper, I can clearly read through graph paper. I have a notebook at my work that is this graph paper. It's like a little notebook, but I write on this stuff all day, every day.
Thank you.
All right, so for the next problem, get that back. So for the next one, this is where we're having some transformations, right? So a couple of things to keep in mind. Remember, for this one, if we replace our xy, right, by x over a comma y, then that's where we could get those transformations. Sometimes students don't feel as comfortable with these sort of transformations. So it's also, if you don't use that, it's also 100% okay if you just build out a table, your XY, like we kind of did in class, and we look at 0, 1, 2, and 3 here. And then when we plug those into our equation, we end up with 0, 1.7, 2.4, and 3. And then we can just graph those. So we have 0, 0. Then we have at 1, we have 1.7. At 2, we have 2.4. And at 3, we have 3. And you can see that sort of transformation. Okay. Again, it's all about making sure that you put enough work. So if you do make one small error, I'm able to still give you partial credit because you put enough work to show that you understood the concept, okay? So you're welcome to use calculators, but you still have to show your work, right? So calculators, I'm not going to say you can use them on question 2, but not question 3 or 4. That's just confusing. So you have to show your work. So even if you get an answer out of the calculator, you have to be able to put the work behind it on paper in order to get credit. And then you think of just using the calculator more as a way to check that you've done what you did correctly, and not as a way to just get a final endpoint solution. Does that make sense? Okay. So for this next one, this one is, again, we can think of this also, and we can replace our xy by x and then a times our y. So in this case, our A is 3, right? Or we could build our table of 0, 1, 2, 3. So this is going to be 0, 3, 4.2, and 5.2. So when we plot that on here, we still are at 0, 0. We're at 1, 1, 2, 3. We're at 2, 4.2, and 3, we're at 5.3. So we're going to be a little higher arched up there. Okay? Question.
How did you get 4.2 and 5.2 again?
You plug them into here. And so ultimately you're going to have 0. So you could do it like this, right? Or you plug 0 in here. 3 times 0 is 0. You plug 1 in there. 3 times square root of 1 is 1, 3. So then you plug a 2 in there. The square root of 2 is, so 3 times the square root of 2 gives you 4.2.
Okay, thank you.
And then 3 times the square root of 3 gives you 5.2, roughly rounded. Okay. All right, so next we want to summarize these transformations. First, let's look at this and determine what is our parent function, right? So our parent function is given here. This should be an x squared. So our parent function is x squared. When we look at our vertical shift, right, that's this right here. That's telling me we're having a vertical shift up 3 units. Our horizontal shift, this right here, that's really, remember, that's x minus -2 squared if we're looking at it in standard form. So we're actually shifting left 2 units. Okay. Then when we look at our vertical shrink, stretch, horizontal shrink, stretch, there's actually none of those in that problem. But there is a, I already used purple. Let's use this one. There is a reflection here, and it is reflecting the x-axis. Okay. And again, you're not able to use notes on the exam, but in your studying prep, just use, remember at the end of last class period, I gave you in these PowerPoints, I gave you some, like where all of the rules that we looked at are all combined into one sheet. So you can look at those to kind of study and prepare for the exam. Okay, question? Now we're into the material that we covered today. So a little bit of a refresher again. We're looking to do the symmetry test. So is this symmetric with respect to the x-axis? Remember, we're changing all of the x's to a negative x. So this gives me y equals the absolute value of negative x plus 2 times negative x plus 5. This simplifies to y equals the absolute value of x minus 2x plus 5. This is not the same as my original equation, so no, there is not symmetry with respect to the x-axis. Okay, looking at with respect to the y-axis. Now we're looking at with respect to the x-axis, we change our y, so that's negative y equals the absolute value of x plus 2x plus 5. let's simplify this, getting the y back to positive. We have y equals negative absolute value of x minus 2x minus 5. Again, that is not equal to our original equation, so there's no symmetry with respect to the x-axis. And now let's switch both of them. So we have negative y equals absolute value of negative x plus 2 times negative x plus 5. When we simplify this, we end up with negative y equals absolute value of x minus 2x plus 5. Now one more time, let's get the y positive. So if we divide everything or multiply everything by a negative 1, we get y equals negative absolute value of x plus 2x minus 5. And that is not our original either. So this problem here has no symmetry. Okay, question. Okay, so looking to see if a function is odd or even. So remember, we're going to do negative f of negative x. So we're plugging that negative x into everywhere. We have 11 times negative x cubed plus 12 times negative x. When we simplify this, it's negative 11x cubed minus 12x. This is not equal to our original function, so it is not even. Okay. So now let's test and see if I can get negative of my entire function. The negative of my entire function, remember, that's where we just change all the signs in the original equation. So that is negative 11x cubed. It only changes the sign. Yeah, change all the signs in our original equation. And that gives me negative 11x cubed. You could see that is equal to, so that does equal f of negative x. Therefore, this problem is odd. It is an odd function. Okay, question. Okay, for this problem, you're going to be asked to graph a piecewise function. Okay, so again, it's really important that you label your graph. So for the first one, we have negative 4x plus 7. That means we can put our first dot at 7. So here's 1, 2, 3, 4, 5, 6. Here's 7. Okay, and our graph slope is negative 4 over 1. So we're going to drop 4, 1, 2, 3, 4, run 1. So that's our rise over run. Okay, so I'm going to just do a straight line so that that graph, that line looks something like that. Okay, and it's going to go off into infinity in both directions. But remember, this says for x less than 1, negative 1. So here's x is less than negative 1. So this is actually hollow, and all of this is not part of the graph. Okay? So that's for the red one. Now let's look at the green one. The green one, we can go, if you recall, we would have our x squared is here, 2 is up at 1, 2, 2 squared is 4, so that's 1, 2, 3, 4. So it looks a little bit like this, except we need to shift it up 2 units, right? me undo that. So we want to shift it up 2 units. So that's 1, 2 units. And that's what that one looks like, except this one is -1. It is equivalent. So here's -1. So we have a solid. So it's none of this, but we have a solid dot on here. And it goes this all the way up into here, but it stops at hollowed with a 5. So we have 1, 2, 3, 4. Here's 5. Comes all the way up here. Let me make it go up a little more. And 1, 2, 3, 4, 5. So we have a hollow here and then none of this part of the graph. Okay. And then our blue is 6, and so it is at 5. So technically here's 1, 2, 3, 1, 2, 3, 4, 5, 6. That's y equal to 6, right? But it's only good at greater than or equal to 5. So here's 1, 2, 3, 4, 5. So we have a solid dot here, goes off this direction and none of this. Okay? So if we're looking at this piecewise, just this piecewise, we're looking at, let me do just yellow. So we're just looking at this piece, and that is all that is actually included in that graph. Okay. Now, if I asked you to evaluate some points, if I had said something like evaluate, I don't know, f of -2, right? You could do that, right? You could say, I could do it graphically or I could use my equations. I could go, well, -2 is here, so that must be on the red equation. And we see that because that says less than or equal to 1, -1. So that would be -4 times -2 plus 7. So that is 8 plus 7, which is 15. Okay. Similarly, if I had said, what is f of 7, right? Then you would have said, well, my x is 7. 7 falls here in this one, and thus that would be equal to 6. Okay? Any questions? All right, so this graph, we're looking at where do we increase, decrease, or stay constant. So for this graph, we're increasing on this portion. We are decreasing on this portion. And we are constant on this portion. Okay? So let's go ahead and we're increasing on the interval from -infinity to -2. We are decreasing on the interval from x equal to -2 to +2. And we are constant from +2 to 4. Because you can see we end. So this one went to infinity because of the arrow. This one doesn't have an arrow, so we actually stop at 4. Okay? Questions? Okay, so this one, not a lot of work here. We just looking what is our minimums, what are our maximums. So we have maximums at these 2 points here. That is at the point -1, 1 and the point 1, 1, right? And we have a minimum at this point here, which is 0, 0. Okay, questions? So for this one, we're going to look at some of those functions. So this one is looking at our f function divided by our g function, evaluated at -6. So this is going to be f divided by g. And we want to evaluate that at -6. So that's 5 times -6 divided by the absolute value of -6 minus 2. So that is -30 divided by the absolute value of -8, which is -30 divided by 8. Okay, so that is -15 divided by 4. You'll want to make sure and simplify as much as you can so you don't lose a point for not. Okay, questions? Okay, so for this next one, we want to evaluate just our f minus our g function. So for this one, we would have 6x minus x squared plus 3x. And we also want to state our domain, but let's distribute this negative to both pieces. So we have 6x minus x squared minus 3x. So this is 3x minus x squared. There's no restriction on our x values because there's nothing in the denominator. There's no radical square root value that we have to be greater than. So for this one, our domain is going to be all real numbers. And so it'll go from -infinity to infinity. Okay? Any questions? So this one is, we have our g of f of 2. So we want to evaluate our function at, we want to evaluate our function. First, we want to determine what is f of 2. F of 2 is 2 cubed minus 3 times 2. So that is 8 minus 6, which is 2. Okay, so now we take that g of 2, we're really plugging that 2 into here, and that is the square root of 3 times 2, which is the square root of 6. We can't simplify that any further, so that would be the solution. Okay, questions? Okay, so for this one, we have n of x equals x minus 1, m of x equals x squared plus 7. And we want to do the composition. I don't know where that p came from, but we want to do the composition of n of m of x and state the domain. Okay, so for this one, we have n of m of x. That is n of my m function, which is x squared plus 7x. Okay, so we plug that in to our n function. And so that is x squared plus 7x minus 1. So we can really just move the parentheses, and that is the solution. No restriction on our domain, so our domain is -infinity to infinity. Okay, questions? So for this one, we want to decompose an equation. So like we did a little earlier, this could be the insides of an equation, right? It could be just x squared here. So if I'm looking at, I should probably put that I want to know what f of g of x is equal to h of x, right? Like we did in class. And so when I do that, then that's really just saying my f of my g function. So I've substituted g into f. Therefore, my f function is going to be the x squared, and my g function is going to be what I plugged into it, which was x minus 5. So not a lot of work needed for this problem here. All right. So that takes us to the end of the types of problems that you'll see on the exam. Do you guys have any questions, comments, concerns, anything of that nature? All right. If you guys don't have any questions, that is all of the material I have for you tonight. I am not posting the written review in Canvas, but there is a blank copy of the review in Canvas for you. And then you can always rewatch the video to get more of the review if you missed out on it in your notes. Okay. All right. Any other questions? The tutoring center should absolutely be able to help you with this course. All right, if you guys don't have any questions, that's all the material I have for you. Again, remember, no class next Monday. That will be designated time to give you to take the exam. And then of course, if you have any questions between now and then, feel free to shoot me an email and I will get back to you as soon as possible.
Professor, will there be any homework for next week or no, because we have the test?
The homework is just section 1.7 and 1. Is it 1.7 and 1.8? So there are 2 homeworks that will be due next week, in addition to the exam, because you've got to do the homework to prepare for the exam, right?
Oh yeah, because it's okay. Thank you.
Uh-huh. There will not be any homework. No, there will be no new homework next week. Do the following. Does that make sense? So you only get homework after you get lectured on material.